Alright everybody, we're going to pick back up on 4.4 where we left off. We had just filled out the chart where we learned about the names of the different degrees and the leading coefficients. So let's get some practice with it. Example 1. What is the degree, or what are the degree and leading coefficient of 3x squared minus 2x to the fourth minus 7 plus x cubed? Now notice below it says, rewrite the expressions so that the powers of x are in decreasing order. This is called standard form. You may be familiar with it. We've talked about the word standard form for multiple types of equations. What standard form means for polynomials, because they obviously come in all different shapes and sizes, is that you have to take your term with the highest exponent, and you move that whole term to the front. Then you look for your next highest exponent, and you put it next. Then you look for your next highest exponent. And then finally, you'll end with the constant. So, once we put this in standard form, we see that the degree is 4. Our largest exponent is 4. Sorry for the world's tiniest box. And the leading coefficient is the number out front, which is the -2. And if you remember, what the leading coefficient does is it multiplies the rate at which that function is growing by. That a value is a stretch factor or a compression. And the negative would make it to where it reflects over the x-axis. So those rules that we learned back in our previous chapters are still true for polynomials. So let's come back to those. Let's try a couple of these here. So it says, state the degree and leading coefficient of each polynomial in one variable. We won't be looking at polynomials in multiple variables. All right, and when you look at this, there's only one example that has multiple variables, and it's this guy right here. And if things went like normal this year, at some point somebody asked, Mr. Cottle, what order do you put things in if there's multiple variables? Well, the standard form process that we just saw doesn't really apply because you don't know which powers to put first. So really, in terms of dealing with polynomials, there's not a standard form for multiple variables. I mean, you can put the highest exponents out front still, but then you'll sometimes have like hybrid variables like that. So the rules are a little more different, and we won't look at ones like that. But what it wants us to do is state the degree in leading coefficient. Now, you don't want to assume that they are in the standard form. This first one is. You can verify that because the exponents are decreasing. So this one's degree is 4. Degree is the exponent. The leading coefficient, I'm going to call that the LC. The leading coefficient is 3. So for number 2, hopefully you can look and see it's not in standard form, and that the 7 is your degree. It says degree 7 polynomial. And then your leading coefficient is the number out front of the term with the highest degree. So that's a pretty basic concept. I mean, even if it gets scary looking. What's the degree? Highest exponent. There's your degree right there. What's the leading coefficient? The number that's with the highest exponent, which in this case there's an invisible 1 in front of that x. So this one's leading coefficient is -1 over 25. All right, and that's all it is. Right, highest exponent, and then the term with, or the number that's with the term with the highest exponent. All right. This skill here is a throwback skill. We did it some last chapter when we were evaluating quadratics to find more coordinate points for our table. It's function notation. F of -5 says find it if f of x is x cubed plus 2x squared minus 10x plus 20. So what that means is, here's our function. They want us to figure out, what do we get if I plug in a -5 everywhere that there is an x. Now you do want to use parentheses. And here's something else you can do. F of -5 is just the set of instructions. It's not going to change for the rest of the problem. It'll be a part of the answer. Because it's telling your audience, hey, I used function f, I plugged in a -5, and here's what I got. And we're about to find what we get. The only thing that might be a little bit different is that there's other exponents other than squared. So notice how I left myself parentheses everywhere there is an x. And I'm going to replace it with a -5. And then we simply evaluate. So -5 cubed is -125. 5 squared is 25 times 2 is 50. -10 times -5 is a positive 50. Then there's a positive 20. So if you look, 50 plus 50 plus 20 is 120. Add that with the -125, and you get that f of -5 is equal to -5. So that is a coincidence that they landed at the same number. That's definitely not always going to be the case. And that's a coordinate point, and that's what this function notation does, is it is essentially telling us that, and this would be your x coordinate, this would be your y coordinate, that -5, -5 is a coordinate point on that function. And that's why we were able to use this method last chapter to find more y values for our quadratics, because anytime you substitute in an x, you're finding a y coordinate point. This next one's going to be the same concept. It's going to be a little bit more tricky, because what we're plugging in is no longer just a constant. It's a squared minus 1. We work with this in mathematics is called composition of functions, where we'll put, an equation such as a squared minus 1, or a function a squared minus 1, into another function, and that essentially allows them to kind of team up to where instead of calculating one thing and then taking that number and plugging it into a second function, if you do this, which is called composition of functions, where you're putting a function inside of one function, and it'll have a different notation later this year, it allows you to do two things at once, essentially. So you could really think of it as, if you had to cut a bunch of pieces of paper, like the homework slips I give you, I make copies and stack them all up, and then when I cut them, I'm cutting multiple pages at once. So it's kind of organizing things so that multiple things is happening all at the same time. To accomplish this, the steps are the same. Everywhere I have an x, I'm asked to substitute in an a squared minus 1. And it's going to get a little bit more tricky. And the reason for that, and we learned this in Pascal's triangle, I cannot simply just square that and that. Really what's happening for a squared minus 1 squared is, I'm going to take it over here, when we're doing a squared minus 1 squared, it's really having us do this. And we'll need to FOIL it out. And when we do that, we'll get an a to the 4th, a minus a squared, another minus a squared, and a plus 1. And when I combine those like terms in the middle, we have 2, then they're negative, a squareds plus 1. So that's what I need to carry back over, because that's what a squared minus 1 squared is equal to. So I'm going to take that over here. So it was, this piece here, was a to the 4th minus 2a squared plus 1. right, and that's all. So it's just a couple more steps. Here we get to distribute. So we'll have plus 3a squared minus 3. Here's the constant. And when we combine some like terms, there's some like terms. Here's some like terms. We get a to the 4th plus a squared. Almost forgot this one here. And then when I add all the constants up, which is -7 plus the 1, we get that. And this stays the same the whole time, because it's just telling our audience what we did. And what we did is we took equation G, and everywhere there was an x, we substituted in a squared minus 1. And that's what we get. So when you plug that in, your answer is a to the 4th plus a squared minus 6. All right, and that's about it for the front side. And here's some practice for you, but it's the same concept as up above. Everywhere you have an x, so we can do one here. I'll just pick the f of -5. It says to do both, but I'll just pick one here. We substitute in the -5. -5 squared is 25 minus 9. F of -5 is equal to 16. All right, so this backside is best going to be done in person because it's kind of an explorative thing. All this in the chart is going to look intimidating, but it's just the ending behavior we did in Chapter 2. So that'll come back to you very quickly. But some of the stuff's important moving forward, and it's not very complicated. But when you listen to it and can't ask questions, you might develop some of the wrong ideas. So we will have to cover this backside once we return.